In section 6.3, we're going to talk about something that are called complex fractions. Complex fractions are fractions of fractions, which means you have one big fraction that has fractions on top and fractions on the bottom. Now, it may have one fraction on the top or one fraction on the bottom, but it has at least one either on the top or on the bottom. Well, then you have to kind of think about, what does this mean? You are dividing two fractions. That's what that big division symbol or fraction symbol means, is that you are dividing. Well, how do you divide two fractions? We talked about this earlier. If it's just one fraction on the top divided by one fraction on the bottom, then we can do what we already did in this section, which is then we can do keep, change, flip. We did this at the beginning of the chapter. The keep, change, flip, remember, means keep the first fraction. You change, that's the C, you change the division into multiplication, and the F means you flip the fraction you were dividing by. Keep, change, flip. So it would mean that we wouldn't be actually doing anything new as long as we have one fraction on top and one fraction on the bottom. Well, notice, if we look at the first example, A, and we look at the division here of the two fractions, we've got one fraction on top divided by one fraction on the bottom. So we can go ahead and just do keep, change, flip. We'll keep the first fraction, 2/3. We'll change the division to multiplication, and we will flip that second fraction, and it will turn into y over 2x. Now it becomes, how do we multiply fractions? Well, we did this way back when at the beginning of the chapter. Remember, when you're multiplying fractions, you actually reduce at the beginning so that your final answer just comes out reduced when you multiply straight across. Well, remember, we can reduce anything on the top with anything on the bottom. Well, we have a 2 on the top and a 2 on the bottom. So I can divide both of those by 2. Well, 2 will go into 2 once, and 2 will go into this 2 once. So what's left over, because there's nothing else I can reduce? Well, on top, I end up with a 1y, and on the bottom, I end up with a 3 times 1, which is 3, and an x. Well, the only thing that's really not necessary to write is the 1 in front of the y, so I can rewrite this as y over 3x. And I'm done. Moving along to problem B. Notice we have the same thing going on in B. We have division involving just one fraction on top, and we have one fraction on top and one fraction on the bottom. So we can again do keep, change, flip, meaning we keep the fraction on top, the 5x squared over 4yz, and we change the division into multiplication, and we flip the fraction we were dividing by. So if it flips upside down, the z squared will now be on top, and the 15xy will be on the bottom. Now again, remember, with multiplication we can reduce first, which means we look at the 5 and the 15, which are both divisible by 5. 5 will go into 5 once, and 5 will go into 15 3 times. I can also cancel out some x's. Notice I've got 2 x's on top and an x on the bottom, so I can cancel out one of the x's on the bottom with one of the 2 on top. Notice I can also cancel out one of the z's. I've got a z squared, or 2 z's on top, and a z on the bottom, so I can cancel out one of the z's on the bottom with one of the two on top. Let's see what's left over. Well, on the top, let's see what I've got. I've got a 1xz. Well, I won't have to write the 1 in front of the x and z, so I'll just have the x and z. On the bottom, I have a 4y and a 3y. Well, 4 times 3 will just get you 12. And the y times the y will get you a y squared because they're both on the bottom. You can't cancel them. You have to just combine them. And so that's our final answer. It's xz over 12y squared.